Oxidation numbers are how we keep track of the electron movement. In some cases, it's going to be very similar to the charge of an atom, but keep in mind it's not always the charge. So oxidation numbers, there's a certain order we go through the rules. You'll always start out with any element that could possibly have a 0 oxidation number, and that'll be any element that's alone in its normal state. An example would be if I looked at copper. If it's listed in an equation all alone, then its oxidation number is 0. And we normally will write the oxidation numbers above an element. Let's say, though, that you have chlorine, and it's Cl2. Now, it might go through some reaction and end up that it has 2 chlorine ions. But because it's diatomic, while it's shown diatomic, it will have an oxidation number of 0. Sulfur is sometimes considered to have a 0 oxidation state when it's shown alone, but technically sulfur is usually not alone. It's usually with 8 total sulfurs, and that's usually when it will be considered an oxidation number of 0. And similarly, in some cases, they may show phosphorus alone. If you have an equation that shows it alone, then consider it a 0 oxidation number. But technically, phosphorus usually is not found alone. It's usually found with 3 others for a total of 4. And that's usually when you'll consider that oxidation number 0. Hydrogen will normally have a +1 charge. And that will be because hydrogen is usually the first thing in a compound. Remember that the first thing in a compound is the cation with a plus charge. The second element shown has the negative charge, and that's the anion. And in this case, hydrogen will have a +1 charge. It also happens to have a +1 oxidation number. To balance this, the chlorine will have a -1 oxidation number. The exception would be when hydrogen is shown in a compound and it is the second element. That's telling you that it is the negative element. And you may also know by electronegativity that calcium will be more electronegative than hydrogen. So in this case, if we have CaH2, the hydrogen, because it's the second element, it will have a -1 oxidation number because it has a 1 negative charge in this case. And we can go ahead and go to something we're going to learn here in a second, is that each hydrogen has a -1 oxidation number. Oxidations are always each. There are 2 of them. 2 times a -1, it gives me an overall of a -2. So calcium would have had to have a +2 oxidation number to balance. When you add up all the oxidation numbers of a neutral compound, they have to equal 0. I've already given you HCl. At that time, I had told you that hydrogen will have a +1. As long as it's the first element in a compound, then it's going to have a +1. This whole compound has no charge. Therefore, the chlorine would have to have a -1 oxidation number so that this +1 and the -1 will total to 0. Oxygen will usually have a -2 oxidation number. Example would be CO2, in which case the oxygen, each one of them would have a -2 oxidation number. And because there are 2 of them, that gives you a -4. Because the entire molecule has no charge, that brings us back to a +4 oxidation number for the carbon. Exceptions to oxygen's oxidation number will be peroxides. And peroxides are when you have an O2 ion, but it has a 2- charge. Common examples would be hydrogen peroxide, H2O2, and sodium peroxide, Na2O2. In each case, that oxygen, each one of them will only have a -1 charge in order for the O2 to have a total of a -2, making the sodium, each one have a +1 charge, and the hydrogen would have a +1 charge, which is also its oxidation number. Now, superoxides are when the O2 ion has just a minus charge. And the examples will be when it is with potassium, making it KO2, rubidium, RbO2, and cesium, CsO2. Those are the three alkali that will form with O2 to make a superoxide. And in this case, the oxidation number is actually a -1/2, which is really strange. But that would make the -1/2 with the 2 is what gives it the -1 charge. And the cesium will be a +1, potassium +1, and rubidium +1 oxidation numbers. The other example would be when oxygen is with something more electronegative. And the example you're probably going to see on a test question would be OF2. In this case, the halogen fluorine would have a -1 oxidation number. Because there are 2 of them, that makes a total of a -2, giving your oxygen a +2 oxidation number. Group 1A ions have a +1 oxidation number. Example would be sodium. As an ion, sodium would have the 1+ charge, and its oxidation number would be +1. Again, the charges and the oxidation numbers aren't quite the same thing, but they definitely can be used as a method to keep track of them. Ions that are in group 2A have a +2 oxidation number, such as calcium. If calcium has a charge, then its oxidation number is a +2. The group 7A ions are a -1 oxidation number. Example would be HCl. The Cl would have a -1, and we've already learned that the H would have a +1. And this is going to work out really well to the rule that overall it has to balance to a 0. An exception would be if the halogen in 7A happens to be with some element that is more electronegative, such as in this example that I gave you of HOCl. We've already learned that hydrogen, especially if it's shown at the beginning of the formula, would have a +1 oxidation number. Oxygen should have a -2. So working this out, we want this whole compound to have no charge because it doesn't show it's an ion. So if the hydrogen has a +1 and the oxygen has a -2, the chlorine in this case is going to have an oxidation number of +1. The sum of the oxidation numbers in a polyatomic ion have to equal the ion charge. An example would be if we had H2SO4. This SO4, the sulfate polyatomic ion, it has an overall charge of 2-. That means that this polyatomic ion has to come up to a 2- or a -2. If each oxygen is a -2 and there are 4 of them, that means I have a -8 so far, and I want it to end up with a 2- for the sulfate portion. That means that sulfur had to have a +6 oxidation number, because the +6 and the -8 will give me the -2. And that does work out properly because my hydrogen should have a +1, and there are 2 of them. So I have a plus 2 here. And this plus 2 and the minus 2 balance to 0. That meets my other rule that overall it has to have a 0 overall.